Sugars. Again, one of your learning objectives is to be able to identify or draw a sugar, a disaccharide based on, hey, if you're given two different sugars. There are three disaccharides that I want you to be familiar with. They are sucrose, lactose, and maltose. I want you to know what they're made up of. And I also want you to be able to identify them and classify them by a couple of different rules. So we'll start out with sucrose. Sucrose consists of glucose and fructose. So that's kind of glucose and glucose because if you remember, fructose is the ketose version of glucose, and glucose is an aldose. So there's so many different ways that you can describe and classify molecules, but you could look at sucrose and say, oh, well, that's an aldose and a ketose, and you'd be right. Lactose is galactose and glucose. Maltose is glucose and glucose. Okay, so let's look at sucrose first. On the left-hand side, we've got glucose. We know that because at carbon number 1, 2, we've got an OH going down. 3, it's going up. 4, it's going down. Okay, so there's glucose. Now, for um, the bond between our two different subunits, what type of linkage is it? Well, first of all, it is a glycosidic linkage. And this is a nice glycosidic linkage because, well, it's going down. And then this is a 1-2 glycosidic linkage. This is known as an alpha beta glycosidic linkage. These are our two anomeric carbons. Let me go ahead and erase that, highlight or circle, circle. So we've got two anomeric carbons there that make up our bond. This is a non-reducing sugar. And now we're just gonna, as I progress through, it's just gonna populate with all of the other details about it. So glucose, fructose, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. This is an alpha 1 beta 2. And you might be thinking, well, why? Why? Well, remember, carbon number 2, our anomeric carbon, when we want to designate a sugar as being alpha or beta, what we want to do is we want to look at, okay, my OH group versus this group right here. Are they going in the same direction or opposite directions? Well, I don't have an OH group on carbon number 2, but I do have it going to a glycosidic linkage. So this, where I'm putting a star, that oxygen is in effect my OH group. That's going down. Group number 6 is going down. So they're going in the same direction, which is why this is a beta form of fructose. Now, if you're thinking, well, and sorry, let me just address this more clearly. If you compare that to glucose, carbon 1, OH is going down, carbon 6, it's going up. So that's an alpha sugar. So we've got alpha 1, beta 2, glycosidic or diglycosidic linkage. All right, sucrose is glucose and fructose. This is a sugar that's nice to give you a little bit of space for it because what we've got is an alpha version of glucose and a beta version of glucose, where when we depict it this way, it's a little bit, might be a little bit more clear because in both cases, or in both of these sugars, in this depiction, we've got our anomeric carbon on the right-hand side of our molecule. All right, then, and if you're thinking, well, what's changed? Well, this carbon number 6 and this OH group, they're going in the same direction. They're both going up as opposed to in this model where they're both going down. Still a beta designation. Then, let's see, lactose, glucose and galactose. On the left-hand side, what do we have? Well, in this sugar, which one is this? Carbon number 2, 3, 4. You might have been tempted to say, oh, well, that's glucose, but you've got to look at the positions of those age groups. Down, up, up. So this is galactose. Another thing to remember about, or sorry, you could have figured that out by process of elimination and knowing that glucose is down, up, down. Alternatively, you could look at it and say, aha, glucose and this have OH groups on carbon number 4 going in the opposite directions. Galactose is the C4 epimer of glucose. So this one right here is glucose. Now I'll give you a second to think about, well, what type of sugar is this? Or how can I describe my glycosidic linkage? And is this reducing or non-reducing? Okay, so first of all, we know that it's a glycosidic linkage. That glycosidic linkage is right here. Our anomeric carbon on galactose is right there. This is carbon number 4 on glucose. Okay, so that's a 1,4 glycosidic linkage. And this is a beta 1,4 glycosidic linkage. Now, the next question is this a reducing or a non-reducing sugar? Well, this is a reducing sugar. Well, what's the definition or what's the criteria that we're looking for to define something as a reducing sugar? Well, it's got a free anomeric carbon right there. So that's a reducing sugar. So lactose is reducing, sucrose is a non-reducing sugar. And it's a beta 1,4 glycosidic linkage. Next, or last but not least, is maltose. Let's go through a series of questions. We know that this is glucose and glucose. Is this reducing or non-reducing? And then what's the linkage? I'll give you a second to think about that. I'm going to take a sip of my coffee. Done. Anomeric carbon, anomeric carbon. Done. Question is, are both of these anomeric carbons involved in glycosidic linkages? Well, the one on the left, that is. What about the one on the right? Oh, that's a free anomeric carbon. So when we identify a free anomeric carbon, this can participate in a redox reaction, a reduction, which is why this is the reducing end, because it opens and closes. So this is a reducing sugar. Now our linkage, okay. What we're looking for is this is a 1,4 glycosidic linkage. Is it an alpha? Is it a beta? Is it a gamma? Oh, there's no gamma. Is this an alpha or a beta? Well, carbon 6 is going up. Carbon 1 is going down. They are going in opposite directions. So this is an alpha 1,4 glycosidic linkage. Another question that might surface is, well, this sugar right here on the right-hand side, is this an alpha or a beta? Well, OH is down. That is up. So this is an alpha sugar. Okay. I hope that was helpful. And know these, know what they're made up of, be able to identify the linkages and be able to identify is it a reducing or a non-reducing sugar. All right. Have a good one.